Hello friends, welcome to Prismatics online class. In our today's class, we are going to look at what derived quantities and what unit. In our previous class, we defined what we call fundamental quantities, where we said that fundamental quantities are those quantities that are capable of what existence, that they can exist on their own. They are independent. They don't depend in any other or source. They can exist alone. We even give example that your daddy in your family is what fundamental quantity of the family or fundamental unit of the family. While your mom and other children and other this in the family are what derived quantities. So today we are going to look at what derived quantities. Okay, derived quantity. The quantity which are expressed in terms of fundamental quantities are called derived quantities. They are dependent quantities. Yes, derived quantities are those quantities that can what depend in another quantity. In fact, without fundamental quantity, derived quantity will not exist. So derived quantities are those quantities that depend in what fundamental quantity. Example, your mommy in your family depend on your dad, and your dad depend on God. So that is in the children depend in the families, the mommy and daddy. So mommy and children are what fundamental quantities. They depend on the daddy, and why the daddy is what for. Okay, mommy and the children are derived quantities, and they depend on their dad, and their dad is called fundamental quantities. So fundamental quantities are those quantities that are capable of existence. Why derived quantities are those quantities that cannot exist. They cannot exist on their own. They cannot exist alone. They must depend in what fundamental quantity, and that is the only thing about it. Okay, example of them are, let's see them. Examples: area, volume, velocity, acceleration, pressure, force, momentum, impulse, density, work, power, energy, etc. Moment of a force. All those things are what they are derived what quantities. They only depend on what fundamental quantity. In other words, when you bring a fundamental quantity, bring another a fundamental quantity, allow binary operation to act on them, either by division or by subtraction or by addition or by multiplication. When you combine them together, either by addition, when you combine two fundamental quantity, two or more fundamental quantity, either by division or by subtraction or by multiplication or by addition, if you combine them together, they will give birth to what derived what quantities. I hope you understand it. Okay, now let's look at derived unit. Derived what unit? Derived unit, the unit which are expressed in terms of fundamental unit are known as what derived unit. Yes, those units that are in fact they are derived. The unit are formed from what fundamental unit are called derived. They depend on fundamental what unit, and that is all about what derived unit. Okay, look at the summary of it on the table here. We have series, quantity, the formula, unit, and what symbol. Area, we know that area is length times what? Length times width. And length is just a distance from a point to another point. Breadth is the same, a distance from a point to another point. So we have it as length times width, which is, and length is measured in what? Meter. Meter times meter will give us meter square. Now, volume is the same thing as say length times width times what? Height. Length times width times what? Height. And all is measured in what? Meter. So that is the reason why we have meter times meter. We have it as what? Meter cube. So we have another one called velocity. What is a velocity? Velocity is defined as the rate of change of what? Distance with time taken. So you talk of distance, you talk of what? Time. And the distance is measured in meter and time is measured in what? Second. So when you put them together, we are going to have them as meter what? Per second, and which is meter per second. By a lot of indices, you have it as meter per second. So that is it. Law of indices say that division is what? Subtraction. So the denominator here is s power 1. So when the s is coming up, the positive integer, positive power here will turn to negative. If it is negative here coming up, it will turn to what? Positive. That is the reason why we have it. Either you say meter per second or you say meter per second. So a lot of indices allow us to operate like this. Did you get it? Okay. Now let's look at density. When you talk of density, you talk of what? Mass per volume. Mass, we know mass, we use what? Kilogram. So the mass, the unit of mass is kg, kilogram. And the volume is what? Meter. We know that volume is L times L times L. That is length times width times what? Breadth. Or length times what? Breadth times height. So which is, now the length give us meter per cube. So this is kilogram per meter per cube. That is kg over meter per cube, which is determined by a lot of indices. We can have it as kg meter per cube, and that is it. So we have another one called acceleration. Now, what is acceleration? Acceleration is defined as the rate of change of velocity with time taken. In this acceleration, we see what we call positive acceleration and negative acceleration. And negative acceleration is called retardation or deceleration, and that is it. So when we come to motion, I will explain it more. Okay, so that is it. So, and that is, it deals with velocity with what? Time. And we know that velocity is defined as rate of what? Change of distance with time taken. That is the reason why we have distance over time, which is velocity over time, by multiplication, listen, rule of division and multiplication. When we have meter over second, it means meter over second multiplied by inverse of this, which is 1 over what? Second. Finally, what do we get? Meter over what? Second square. And that is how we get this thing, meter per what? Second square. By a lot of indices, we can call it meter per second square. That is all about acceleration. So the unit of acceleration is what? Meter per second square. Did you get it? Okay. Now let's go to force. Force is defined as what? Acceleration. Mass times what? Acceleration. Mass is measured in kg. Acceleration is measured in what? Meter per second square. Meter per what? Okay. Yes, meter per second square. So that is the reason why we have it as kg meter per second square. Okay. We have another one called momentum. What is the momentum? Momentum is defined as product of what? Mass and what? Its velocity. We know that mass is in what? Kilogram. Velocity is 1 meter per second. That is why reason why we have it as what? Kg meter per second. Okay. Work is defined as what? The product of what? The force and what? Its perpendicular distance. So, and that is the reason why we have force. The SI unit of force is known as what? Newton. And that is the reason why we have it as Newton times meter. We have it as what? Newton meter. But the general accepted SI unit is what? Joule. Okay. Power. We have power as the work, the rate of change of what? Work with what? Time taken is known as what? Power. And power. Work is defined as force times distance over what? Over what? Time, which is now over seconds. Finally, we have it as what? Joule per second, or watt. The standard unit is what? Watt. The SI unit of what? Of power is what? Watt. Or if you take it by the formula, you have this in as the force is measured in joule per second. So that is what we have here. So, and that is all about fundamental. That is all about derived quantities and fundamental what? And derived unit. Derived quantity and what? Derived unit. So we have explained it all about. See it on the board. Go through it. We have more. We have more of it. We have no less than 20, 30 fundamental derived fundamental quantities. So you search for more, write it more, bring it and know, master it, so that when we'll be calculating about dimension, because our next class we are going to look at what? Dimension in the physics. So, and we now begin to know their formulas, know how to put it them, Some of the questions that they used to ask this place, they will say, which of the following is not fundamental quantities? They will give you A, area, B, velocity, C, density, D, mass. Mass is fundamental, so mass is the answer. Sometimes when they say, which of the following is not derived unit? They will say, which of the following is not derived unit? Okay, let's just see this question. Which of the following is not derived quantity? That will give us A, acceleration, B, force, C, momentum, D, time. D is not a derived what quantity. D is what a fundamental quantity, which is time. So you need to master the fundamental quantities. They are about 7, and the other what fundamental other derived quantities, and that is how to do it, so that you'll be able to distinguish this one is a fundamental quantities and this one is a derived quantities, and that is how to do it. Thanks. God bless you. Remember to subscribe to my YouTube channel, Prismatics Online Class. Follow me on Facebook, same Prismatics Online Class. Like, share, and comment. Thank you. Bye.